Whale shark. Size in the ocean does not always mean danger. The whale shark is the largest fish alive, and yet the creatures it consumes are among the smallest things in the sea. It drifts through open water with its mouth agape, filtering enormous volumes of ocean to extract clouds of plankton, fish eggs, and tiny crustaceans. The pattern of pale spots across its dark body is entirely individual. No two are alike, and researchers use these markings to track animals across years and ocean basins. Some individuals have been followed across entire hemispheres, their routes tracing seasonal shifts in food availability with quiet precision. Its unhurried pace is not a sign of indifference. It is the result of a body so finely balanced between effort and intake that urgency would only be wasteful.
Mako shark. Heat is the Mako's advantage. Most fish surrender their body temperature to the surrounding water, their muscles cooling with every degree of depth. The Mako holds its warmth internally, keeping its tissue temperature elevated above the ocean around it. The result is muscle that responds faster, contracts harder, and accelerates more sharply than anything a cold-bodied animal can produce. This allows it to pursue bluefin tuna and swordfish, animals built for speed, and close the gap. When a Mako launches vertically and clears the surface entirely, it is not performing. It is simply a consequence of the velocity required to close a hunt. Everything about its biology is an argument for going faster.
Epaulette shark. When the reef empties with the retreating tide, the epaulette shark does not leave. It stays behind in the shrinking pools, navigating exposed rock on its paired fins, moving between isolated pockets of water in search of trapped prey. Its brain, when oxygen levels fall dangerously low, enters a kind of controlled shutdown, reducing its own metabolic demands until conditions improve. This is not simply tolerance of hardship. It is a deliberate biological response to an environment that cycles between harsh and hospitable. The epaulette occupies the hours and spaces where competition disappears entirely, having paid for that access with adaptations that took generations to develop. Bull shark. Rivers do not stop the bull shark. Neither do lakes, flood channels, or the murky estuaries where salt and fresh water blur together. Its kidneys and specialized glands adjust continuously, managing the salt balance within its body as salinity shifts around it. Juvenile bull sharks have been tracked deep into river systems, hundreds of kilometers from the coast, navigating upstream with the same ease their ocean-bound relatives navigate open water. By moving into environments that exclude competitors, the bull shark effectively hunts without rival. It does not specialize in any one prey, any one habitat, or any one strategy. Its advantage is the refusal to be confined. Nurse shark. Most sharks must swim to breathe. The nurse shark does not. It pumps water across its gills using its own jaw muscles, drawing in oxygen while resting completely motionless on the seafloor. This single ability restructures its entire relationship with energy. Where other sharks burn calories staying in motion, the nurse shark conserves them. It rests through daylight hours in the sheltered spaces beneath reef ledges, sometimes in piles with others of its kind, returning to the same locations so reliably that researchers can predict where they will be. When it does hunt, it does so by suction, pressing its mouth against crevices and drawing prey out rather than chasing it down. Patience, applied consistently, becomes a strategy. Great white shark. The great white shark does not need to make contact to change behavior. Its presence alone reshapes the patterns of every animal nearby. Seals abandon haul-out sites. Fish schools scatter into deeper water. The effect ripples outward before the shark has done anything at all. This influence, sometimes called the landscape of fear, may be as important to the ecosystem as the hunts themselves. When great white populations decline, the animals they kept in check expand, and that expansion carries consequences down through the food web. The shark's teeth are not permanent fixtures, but replaced continuously,
new rows moving forward as old ones wear or break. It is a body designed not for a single hunt, but for a lifetime of
Thresher shark. The upper lobe of the thresher's tail extends as far as its entire body length, a proportion so extreme it looks like a design error until the hunting sequence plays out. Facing a school of small fish, the thresher does not rush in. It coils, builds momentum, and releases its tail in a whipping arc that sends a shockwave through the water. The concussive force stuns several fish simultaneously, dropping them motionless in the water column, where they can be collected without chase or struggle. Underwater footage capturing this in slow motion revealed a level of mechanical precision that researchers had not anticipated. The tail is not a blunt instrument.
goblin shark. The goblin shark exists in a zone where almost nothing else does. Below the reach of sunlight, under pressures that require biological engineering just to survive, it drifts through the deep ocean at a pace calibrated for a world where food is infrequent and energy cannot be wasted. Its jaw does not simply open. It launches forward on elastic ligaments, extending beyond the snout and retracting with prey already secured, completing the strike before the disturbance in the water has time to travel. Its skin is thin enough that the pink of blood vessels beneath shows through, giving it a pale, almost translucent quality under the light of research submersibles. It has been found almost unchanged in the fossil record across millions of years. Whatever it is doing down there, it has worked for a very long time. Hammerhead shark. The shape of the hammerhead's head is often described as strange, but strange by whose standard is worth questioning. Stretched wide across the front of its skull are electroreceptors, distributed across a surface area far greater than any conventionally shaped shark could manage. As it swims, sweeping its head in slow arcs, it reads the seafloor for the faint electrical signatures of animals buried in the sand. Heartbeats, breathing movements, the passive charge of a living nervous system. Stingrays, which rely on burial as their primary defense, are located and pinned with the flat of the hammerhead's head before they can respond. At certain seamounts during specific seasons, scalloped hammerheads gather in schools numbering in the hundreds, circling in formation during daylight before dispersing entirely after dark.
Tiger shark. The tiger shark has been found with license plates in its stomach. Also boat parts, a chicken coop, a fur coat, and a horse's head. This is not a pathology. It is a strategy that has made it one of the most enduring large predators in the ocean. By placing almost no restriction on what it will consume, the tiger shark insulates itself against scarcity. When fish populations shift, it shifts with them. When seasonal prey disappears, something else has already taken its place in the tiger shark's diet. Its teeth are curved and notched along the edge, capable of cutting through sea turtle shell, which most predators cannot manage. The dark stripes that mark younger animals fade as they age, as though the ocean gradually absorbs them into itself the longer they remain within it.